Hi, everyone. My name's Philip Roberts, and thank you for having me. And I want to talk to you about function reactive programming and Bacon, which is a library that implements function reactive programming in JavaScript. That all sounds a bit kind of scary and buzzwordy, so really I just want to talk about how we can make life a lot easier by making it seem a little more complicated. So whenever we're writing JavaScript, especially in the browser, we are working on real-time code. And whenever we're working on real-time code, that kind of implies that we're working on asynchronous code, right? Because we don't want to block. So we can't block JavaScript and wait for a user to click on something. We can't block JavaScript and wait for an AJAX call to complete. User interfaces, by nature, are concurrent in some sense, where multiple things can be happening at once. Unlike business logic, which we typically use in the back end, where things might run top to bottom, in user interfaces, multiple things can be happening at once. And typically in JavaScript, although there's some debate about this in the node world at the moment, asynchronous code implies callbacks. And if anyone has worked with writing callback-based code, you know that writing callbacks implies callback hell, and callback hell implies sad developer. So why do callbacks create callback hell, and why is callback hell so horrible? So the kind of key problem is that we end up inverting our control flow. So when you write non-callback-based code, your code runs from top to bottom. The control flow runs from top to bottom. It's easy to reason about. It's easy to understand. But when we write callback-based code, and we end up having to nest callbacks because we're saying, OK, I would like this piece of code to run. So when I click on something, run a callback, then make an AJAX request, passing a callback. When that AJAX request completes, then finally do something with kind of the results of all these previous callbacks. So your control flow kind of ends up being all kind of inside out, which makes it very hard to reason about and very hard to understand exactly what our code is doing. And the reason for this is that callbacks are basically a black hole. So if anyone's done any functional programming, you might have heard the term a pure function. And a pure function basically takes some input and returns an output. It does nothing else. Every time you run that function with the same input, it will return the same output. It won't change state outside of the function. It won't call methods or functions that affect the world outside of that function. It's like a self-contained thing that's really easy to reason about. Now, a callback is the complete opposite. If you think about what a callback does, is it takes some input, maybe at some time, and then returns nothing. A callback does not return anything because it's run at some undefined point in the future. And if a function doesn't return anything, by definition, it has to be reaching out and mutating state, having side effects, rather than taking input, returning output. So this nature of the fact that callbacks never actually return anything is why you get this like horrible control flow inversion. So I don't want to go into the theory of all that too much because I'm not a Haskell programmer. I just kind of want to dive in and show you how function reactive programming and Bacon work in practice, because I think that's a lot more illuminating as to what the heck I'm talking about. So let's start with a little example. Let's say I'm writing this really simple scoring application, right? So I've got two buttons, -1, +1. When I hit +1, then my score count increases. When I hit -1, my score count decreases. Pretty simple. So how would we write this with jQuery, which is your kind of typical callback-based approach in JavaScript? So here's the code. So first of all, I set up some kind of global state variable representing the total score at the present time. And then I bind, as we do in jQuery, I bind on-click handlers to the plus and -1 buttons and pass them a callback. So here's my callback again. My callback does nothing but mutate external state, which is basically horrible. First of all, we update this total state variable, and then we apply that total state variable, the value of that variable, to the text value of my score div. And as I said before, this function is a callback, so it doesn't actually return anything. It just mutates external state. Exactly the same with the -1 button, except this time we subtract the -1 button. So these two callbacks don't run from top to bottom, right? They run when I click stuff. So that immediately makes them hard to reason about. We can't just read this code top to bottom and understand what's going on. These two callbacks are fighting over the total variable. They're fighting over the state of this input div. So they're kind of dependent on each other, or at least they interact with each other in a way that is not necessarily easy to reason about, particularly if these two functions were in different parts of our code base, starting to get a bit nasty. Think about how if we made this a kind of real-time app where we had updates about the score coming in over a WebSocket connection, how would we plug that into this sort of current state of our JavaScript code? It would get pretty hairy. So what about if there was a different way to reason about this? What if we could represent the kind of clicks on those two buttons as kind of a list of plus and minus ones? So rather than maintaining the sort of current, sort of just the total state, we just represent kind of the whole history of the clicks on those buttons. And what if we could call functions on that list, like reduce, which I'm sure you've seen if you've done any kind of array type operations. So reduce takes an array of values, takes a function which figures out how to convert an array of values into a single value. So here, we're summing up all the values to get a total of +2 in this case. Note, this is not a callback function. This function takes in values and returns values and mutates no external state, so that's a nice function to have. And then once we've got the total of the list, we then update the text value. This code now runs top to bottom. There's no callbacks. It's easy to reason about. I can kind of understand it. But it doesn't work, right? This code would only run once. There's no response to click handlers. It makes sense, but wouldn't actually work in practice in JavaScript as it stands. But if it could run on every click, then this is what we would see. So we'd see, I click on the -1 button, I get a new -1, the sum is updated, and the text value of the div, again, is updated. I hit again, I get a +1, a +1, and if, in a nice, perfect world, dream code, as it were, this could work, we might feel like this is easier to reason about than lots of callbacks mutating state all over the place. So it's kind of like, what if instead of A equals B plus C, which in maths land means A is always equal to the sum of B plus C, but we've kind of hijacked in programmer land to mean assign the value of B plus C to A at a single given point in time, and if B or C change, it will never update. What if we could write code that declared the dependency between A, B, and C, such that if B or C change, A changed? Because that's all we really want to do, right? What if? So this is where Bacon comes in. So Bacon helps us declare those dependencies. So I'm just going to show you how we can rebuild that example in Bacon. It's going to look mental. Just stick with it. It gets easier. So the first thing that Bacon gives us is event streams. So event streams represent a list of events in time, kind of like that array of plus and minus ones I showed you, except instead of being indexed by position in an array, they're indexed by time. So we can create an event stream off of a jQuery object on the click event, and we'll then have a stream of events. So at the moment, I've subscribed to that stream, which is they're kind of like a pub-sub system almost. So I can subscribe to values in that stream, and in this case, I'm just going to console.log the values. So, So when I click on -1, then my event stream has a new value on it. On a value, I console.log it. So by default, this is just the jQuery event, right? I've got all this jQuery junk. Somewhere in there probably shows me what the actual value of that button is. But basically, every time I click, I'm going to get this jQuery event on my event stream, which is going to be console.logged. Now, console.log is a pretty awful way of showing how things change in time. So I've made a little visualization which shows the same information but with a time-based representation. So every time I hit -1, I get a new event on my event stream. If I hit really fast, they appear if there's big spaces. So this is our event stream. It's representing those jQuery sort of event objects. Currently not particularly useful. What I really want is for each of those clicks on that -1 button to just have a value of -1. So we can map event streams. So just like we can map an array, we can say, for every value on the event stream, map, return, or call this function and use the return value as a new value on a new event stream. So here I'm just saying, discard the jQuery event bit. I don't really care about it. Just return a -1. So now, when I click on the button, we get a -1, which is starting to get useful. I can do exactly the same for the +1 button. So hit -1, on my -1 event stream, I get a -1. Hit +1, I get a 1 on my +1 event stream. So I've just done exactly the same, create an event stream and map. Bacon has a shortcut, which is basically just, if you pass in the value, it will just return that value instead of calling the function. So now I have two event streams, one representing the -1 button, one representing the +1 button, and I need to start combining those. So event streams in Bacon can be merged. So we can basically say, I've got my -1, I've got my +1. If there's a value on either of those, push that value to a new event stream, which represents the merged states. So rather than hand waving, this is easier shown on my diagram. So -1s merge in the +1s. Now if I hit -1, we get -1 on the -1s and -1 on the merge stream. +1, I get +1 on the scores, and +1 on the +1 stream. Kind of getting useful. But now all I'm doing is just showing you that I can hit + and -1. We want to see effectively the sum of all the -1s and +1s that have ever been on that event stream, right? So Bacon also give us a scan. So scan is basically the same as a reduce on an array. So scan says, take all the values on the now merged event stream, which is a list of -1s and +1s, and the initial value on the sort of scanned stream will be 0, and then every time there's a new value, call this function, and the function will get passed in the kind of current running sum. So the first time I hit -1, this sum value will be 0 because it's here, and we'll get a -1 on the value, and then we'll return 0 plus -1, which is -1. So to demonstrate, -1. I hit it again, and now we get -2, because we remember the -1, we pass it in as the sum, -1 is a new value, -2. So now I have a running total on an event stream of the current sum. And finally, I can take that running total and just assign it. So assign is much like the onValue method we saw before. So every time there's a value on our score event stream, which now represents the current sum in my scoring app, assign it to the score div using the text function. So now we have a working application. Awesome, right? Looks more complicated, right? Looks insane. But that's just because we've got used to living in callback hell. So this code now runs top to bottom. It now runs with no state mutations. The only thing we could really call a mutation of state is this assign value, which assigns, actually updates the UI, and kind of we have to accept mutations of state to update a UI, otherwise we wouldn't be able to change anything the user sees. So it works. Now, I'm totally with you. The first time you see this, the second time you see this, the third time you see this, you will be probably wondering what the hell I'm talking about. But it definitely gets easier, and the fact that we're not mutating external state makes scaling this stuff up into real applications that aren't just adding numbers a lot more scalable. So I'm going to go through a couple more examples. So the next thing that Bacon gives us is the concept of a property. So a property is much like an event stream, except it has like the concept of a current value in time. So an event stream just represents, it just has a value when something gets pushed onto that event stream, right? Whenever I click the button, then we get a new value on the event stream. Properties have the concept of like the current value, which is kind of like the scanned sum thing we saw before. That was in fact a property. So by way of an example, let's make a little spreadsheet. So here's our jQuery spreadsheet. So we have two divs. When I type numbers, we get 1 + 2 = 3. Nice and simple. Here's the code. So first of all, we create, yet again, external state variables to represent the current values of A and B. On a keyUp event, we grab the value of the input, convert it into an integer, mutate this external state by adding A + B, and then assigning it to the answer value. And we do exactly the same on the second input. And yet again, this code doesn't run from top to bottom. These two callbacks are fighting over the values of A and B. They're fighting over the value of the answer variable. Imagine scaling this up to an actual spreadsheet with, 65,000 rows and 65,000 columns? Like, writing that code would be pretty hellish and pretty prone to bugs. So let's build it up in Bacon. So the first thing we do, exactly as before, is we create an event stream of the current values of the input fields. So again, I get this jQuery object whenever I hit the key up on the first input. As before, I can map it. So here I've created a function which basically just plucks out the actual text value of the field, and I'm using that in this map function. So on every keyUp event on this input, we'll push a new value to an event stream, and then we'll create a new event stream which maps all of those values using this function. So I type a 1, we get a 1. I type a 2, we get 12. I type a 3, we get 1, 2, 3. I can then start composing event streams, and I think this is probably where Bacon might start to click. So before, if I wanted to say, get the input value of a field, convert it to an integer, reject stuff that are not numbers, and don't fire more than an event every, say, 300 milliseconds, because I don't want to maybe recalculate my entire spreadsheet on every single key press. We might want to wait until the user's paused for half a second or so. We can just do that in a way that is really declarative and really kind of easy to read, right? Map, get input value, map, parses an integer, filter, keep numbers, debounce, only trigger events every 300 milliseconds. So by way of example, type a 1, if I type 1, 2, 3, 4, 5, then we get a little pause. It doesn't fire an event every single time, just to save recomputing everything. So I've now composed, in a way that's easy to read, an event stream that kind of represents the current state of that first input. I can do the same on the second input. So 1, 2, 3, 1, 2, 3. I've taken out the debounce, which is why it's triggering loads. So now I have event streams representing the values of the first input and event stream representing the values of the second input. But how do I combine those two event streams? So I could merge like I did before, but merge isn't going to be particularly useful. So I get 1, I get 2, or 32. How would I couldn't use the scan like I did before, because that's going to sum like all the values in history up into this field, which isn't really what we want. We just want to sum the latest two values on either stream, whichever one, and whenever one changes, we want to update the other one, right? Oh. So we can convert them to properties. So this is what I was saying before. Properties are like event streams, but they sort of hold their current state. And properties are easy to create from event streams by just using the toProperty method. And here we're just saying the initial value is 0. So you'll see when I jump to the slide, all the event streams have a 0 on them because that's their initial value. We can then combine two properties using a function. So let's combine A and B using the sum function. and the sum function just returns the sum of its two arguments. Now, it might just be me, but to me, this could not be more clear as to the intent of the program. Like A combined with B doing a sum versus two huge callbacks updating state all over the place. And now, I hit 1, I hit 2, and we get 3. Pushed onto our event stream, which is pretty cool. And this is just the same code, but now we are assigning the result of our sum back to this input field. So assign answer with a value, and I hit 1, I hit 2, I get 3. And what's also quite nice is that because I've done things like only keep numbers, if I type in junk in here, then no new events get pushed to the event stream for that property doesn't get updated, and the input field doesn't change. Whereas if I skip back to the jQuery one, if I type in here, D, we get not a number because I haven't written extra code in here to detect the fact that it's not a number and reject it. Now I could do that, but I'd have to duplicate that throughout this already complicated and horrible callback. So where was I? Is anyone quite excited about this yet? Does anyone hate writing callbacks? Woo! All right. So hopefully you're still with me on loosely what an event stream is, because this is where it gets pretty funky. So if you've ever tried to work with callbacks and Ajax, you'll know that it can be kind of hellish, particularly hellish, more so than just like click handlers, because you're worrying about return values from a server in time. You're worrying about whether those return values are in order. So here's a simple example. So we're doing a sign-up form for a new application, and we would like to check when the user types whether the username that they're looking for is available. So I type my name incorrectly, and we go away, and turns out that no, it's not actually available. So to do this, we do an Ajax call on every key up event. When that return comes back, it tells us whether it's available or not, and we update the UI. Now, I'm not even going to show you the jQuery because it's A, horrible, and B, kind of uninstructive. We're just going to build it up with Bacon, and you'll see kind of how clear it becomes. So exactly as before, create an event stream of the key up events on the input field and grab the input value. So fill, we get fill in the event stream. But how do we do the Ajax calls? So we could subscribe to those events, do an Ajax call, passing in the value on the event stream, and when the return value comes back from the Ajax call, we could update our UI. So we could do that. But hang on, we've just introduced a callback, and we've decided that the whole point of Bacon was to not have callbacks. So how can we get rid of the callbacks? So the leap, and this is definitely a leap and is non-obvious, so think about it for a second, is to realize that an Ajax request is itself an event stream. It's just an event stream that will only ever have one value on it, which will be the return value of the Ajax call. It's obvious, right? So you make an Ajax request. At some point in the future, you will get the result of that Ajax request, which we can consider like a value on an event stream. So if we make that leap, and we use a little utility function in Bacon, which basically helps us create an event stream for an Ajax call using from callback. Don't worry about the syntax of this too much. It's not really that important. Then we can take values on an event stream and create new event streams for each of those values representing the return value of our Ajax call. Really confusing, I get it. But map won't work in this case. So we have this function now which creates our result event stream representing the result for a given query. But we can't just do map, because this Ajax stream returns an event stream, which isn't a value, right? Map requires you returning return values. So we can't use map. But we can use flat map. So flat map for every value on an event stream, so p, ph, phi, phil, create a new event stream using a function. This is our Ajax stream function. So for p, ph, phi, phil, we'll create a new event stream which is going to have at some point in the future the yay or nay return value from the Ajax calls. And then we merge all those event streams back into a single stream. So here's what it looks like. So I type a P. We create a new event stream, which is the Ajax call for the P. When that Ajax request completes, we'll get a new value pushed onto the result stream. When I type ph, then we get ph. When I type phi. But you'll see, because my Ajax requests take a varying amount of time, it's possible that if random nature is good to me, yeah, here we go. So see how this red request here finished before the brown one? Did anyone see that? My UI has now been updated to say that phi is not available, even though I typed phil. And that's because an earlier Ajax request completed after the latest one. Now, if anyone's tried to manage this like using callbacks, you'll know it's like horrendously hellish, because you have to keep track of every single Ajax request you made, keep track of which was the latest one, discard return values from earlier ones, possibly using timers. It just like is mind-blowing. So to fix that in Bacon, we make one change, which is flatmap latest. So flatmap latest says, when I'm creating these new event streams for every value, if a later one comes back before an earlier one, just ignore the earlier ones, because I don't care about them anymore. I just care about the latest ones. So now, it's impossible for me to break this. So here, Phil came back nice and fast. The other three didn't come back, obviously, in time, so they just get discarded, and we just keep Phil, which is pretty cool. So that's basically an introduction to Bacon. I imagine your head will hurt. That's OK. This stuff gets easier. And by way of example, I hacked together a full spreadsheet in Bacon. So this, apart from actually parsing Excel functions, because that would be insane, this spreadsheet is functional. So here, if I type equals A1 times 5, then I'll get 500, because the value of A1 is 100. I can write arbitrary JavaScript functions, so math.sign of A1. I even created a time variable, I guess, like a Bacon variable for time, which just represents the current time at all times. So my whole spreadsheet updates. So here, we're just saying get the sign of the current time. So this is basically a fully functional spreadsheet. And the source code for it is that long. Now, this stuff is just boring junk to do utility functions and stuff. That code handles moving around the spreadsheet with the arrow keys, but the actual logic of setting up the spreadsheet almost fits. If I make it slightly smaller. So that is the entirety of the logic of building a fully functional spreadsheet. I am not going to claim that I could explain to you how this works. I probably can't remember how it works myself. This was hacked together when I was first learning Bacon, and despite having used Bacon, is horrendous. But the fact that it's, 50 lines, and there is no state management whatsoever in there, I think is sort of evident of the scalability that you get when building complex UIs using something like function-directed programming in Bacon, which you just cannot get with callback approaches. So with that, that is pretty much me. If you want to do some further reading on this, I recommend learning some Haskell. I still don't really understand Haskell, but learning the basics has been really instructive in thinking about JavaScript code. The main reason is that in Haskell, you can have no state. Like, it's basically forbidden. So they have come up with techniques to manage how you create stateful applications using a programming language which fundamentally cannot have state. And it turns out that not manually managing state is a really good thing. It's just complicated. And so this is where things like functional reactive programming come from. So yeah, go and learn a bit of Haskell if you're so inclined. Rxjs is, I guess, the original, or one of the original reactive programming libraries that brought those ideas from Haskell into JavaScript. I think it came out of Microsoft. And Bacon, which is not by me, it's by Juha, a guy from Sweden, I think, is basically taken the concepts of reactive extensions and made them nice and easy to play with. So the documentation on the Bacon GitHub is really, really good. This stuff will be scary when you first play with it, but just persevere and it gets easier, I promise. And with that, thanks for listening.